60 out of F minus 1 is 59. Out of FD is minus 72. Over out of F is 60, and that's correct. €19.29,000, I suppose.
So the last part, did you do what's in brackets first? Or
Should that be minus 72?
What?
Should that be 306 or minus 72?
306.
No, the last part with the brackets here.
No, out of F by D is minus 72
Square.
over 60 all squared. And it's written like that in the thing. I think so. I mean, with the brackets, you can put that in this. Is exactly. I put exactly that into the calculator.
online, yeah.
Okay, and what do we got here? Government spokesperson for the Department of Enterprise and Employment claims that the average industrial salary for those working in the IT sector is about €33,000. A spokesperson for a union representing IT workers says that the department is lying and that the true figure for the average industrial wage is closer to 26,000, which we saw earlier. Use your answers part B and C to explain a possible source of this confusion.
I'm going to have to do that here.
It's on the past exam paper. That's a great question.
So this what we found is between 19 and 24. Actually.
Huh?
We found it between 19 and 24. That's what we're saying, no? Our medians, no? The answer to B was 24.5.
Yeah, so the B answer was 24.5, yeah. We also had 26.
Yeah,
and then, but the government is 33.
So they don't use average. Does the median and the average?
There's the median as an average and the mean as an average.
Uses some mean and
So they're using different statistics.
They're using the same value.
Same word, average, but not the same way of calculating the average. So the government used the mean. Or say department. And the union used median. Great question on the paper. Yeah, that's what happened. Do you want a break or do you want to drive on? You lost that one there. Right. So yeah, there are different things I can ask here, so you'd have to look at the examples we did and the exercises.
So that's just your answers, there's no calculations on them?
No. Yeah. Right.
So the 19.9, that's the deviation, that's the X bar, that we're actually going with, so.
That's X bar.
Yeah, so that's
the
what
mean.
we're saying, is it?
That's the mean.
Oh, that's the mean.
Yeah, so the government used the mean, the 33, and earlier on the unions used the median.
Which one is more accurate?
Can't really say. I mean, this is damn lies and statistics. So it's people sometimes people are just deliberately misleading. So if you see anyone saying average, well, you might sound like an arsehole, like myself on Twitter. Oh, is that the mean or is that the median? Like, you know. But that's shenanigans, like, yeah. And that's exactly how it would happen. But I'm not saying that. It depends, like, so when we were doing this, there's plenty of times it's not reasonable to use the mean. So one person earning 1 billion extra pushes the mean income up by €500, which is ridiculous. So basically, if the data is skewed or spread out, or no, skewed, so that say there's loads of people making low And then there's people making really, really high
Yeah,
that
like,
mark.
yeah.
But if it was more like bell-shaped, they'd be similar. That wouldn't matter. Okay.
33 was mean, yeah, and 24.5 is the...
Yeah. What do we got here? Suppose that 2 dice are rolled. What is the probability that the difference between the numbers is odd? Now you can have a shot of doing this kind of in your head, but you're better off just listing all the possibilities. So you put the first dice up here, 1, 2, 3, 4, 5, 6. And the second here, 1, 2, 3, 4, 5, 6. I think in class I actually listed every single pair, but I don't know if that's actually necessary. You can just tick the boxes where the difference, where the event happens. So this one is that the difference between them is odd. So you don't actually have to list them out. If you do this, it's enough.
You only turn around and get an odd number. If one is even, one is odd, is it?
Yeah. But
If you've only either odd or even on the dice, so you've only either 3 out of 6 chance.
there is so what he's suggesting, right, is it is possible to do this using your head as such. So you've got even, odd, or odd, even, and it can be very tricky. So just see what happens there. What's the probability that you get an even? 50-50, and then after that an odd? 50, yeah. So that would suggest a half by half, that would be a quarter. So it suggests 50%, yeah. But you'd be very careful. So if it was ones where, say, it added up to a prime number.
Yeah, I was just looking at it that the only way you can get the difference, the odd, is if you have an even number on one dice and an odd and the other.
You're right, I'm just saying, just be careful. I could ask a harder one where...
That's that
The
one.
prime number one, yeah.
Well, they're different. You just have to go through it. Like I'm going to go through this one, but you see, the thing is, the or means plus, and you can't get even, odd, and odd even at the same time.
Yeah.
But there are other ways where you have 2 things where you can get them at the same time, and to take that one away. So it's going to be easier just to do this. You're dead right, and it's nicer what you're suggesting, but it's safer like this. The prime one, so that they'd add up to a prime number 2, 3, 5, 7, or 11. But you don't do it like as clever as that. You just brute force. So there's a difference between 1 and 1. Odd.
0.
Is that odd?
No.
No. This one is odd. This one is odd. This one is odd. And you're going to have a similar kind of pattern now. Is the difference between 2 and 1 odd?
Yeah.
Yeah. 2 and 2? No. This one, and very quickly you'll see that it's 50-50. So the probability of difference. So I'm just going to write P for probability here, kind of dodgy, but I'll just write P. No, I shouldn't do that. I'm just going to write P of A, where A is the event that the difference is odd, is 18 out of 36, which is a half. Which would be a quarter plus a quarter. So you could have slightly different things here, or maybe there was 3 coins instead, where you'd have to list all the outcomes with 3 coins, or maybe a dice and a coin, something like that. Or most times 2 dice. I think that's the better way to do it. You don't actually have to list all the pairs. Doing it like this is fine. The inverse matrix method. So what you have to do here is write what you have as a matrix equation. What would it be written as a matrix equation?
4.2
Oh, that's grand, yeah.
We won't be able to guess them, won't we?
This is an exam paper. So, yeah, you could write this down again, but to get what you need to do, you need to write it in a kind of an abstract way. So the matrix would be A. The vector of unknowns would be X. And the constants would be B. I don't know, you don't need those lines. And using the inverse matrix method to solve this. So how do you get rid of the A on the left? Multiply by the inverse on the left, both sides. A inverse times A is essentially 1 times X. So X is A inverse times B. Where A is the matrix there, X is the X and Y, and B is the -2 and the 4.9. Now you need to find the inverse of A, so there's two ways to find the inverse of a 2 by 2 or a 2 by 2 matrix. You can use the Gauss-Jordan algorithm that's mentioned below, but there's an easier way. Formula. The formula is in the big tables, not in tables at the back of this. So it's kind of set up A, B, C, D, and the inverse is 1 over AD minus BC. So 4.2 by 6.2 minus BC minus 1.2 by 3.7. Then you swap A and D, and you change the sign of B and C. So I'll just kind of write the formula underneath there. A, D minus B, C, D, A minus B minus C.
And that's only because it's a 2 by 2.
Yeah, for a 3 by 3, as you have here, you have to do the Gauss-Jordan algorithm. So I might sort that number out the front.
Is that formula in the
Big tables that they'll hand out to you, like the log tables. Nasty numbers. So to get X, I have to multiply this by B, which is the -2.7 and 4.9. So I have, therefore, X, the vector of unknowns, is A inverse, which is this. Times B, which is -2.7.
Where did you get 25 over 762?
I put this in the calculator.
1 over 21.6.
1 over 30.48.
Huh? .2, 6.2 minus, which is plus 1.2 by 3.7. No, I get that.
Oh, 30.48.
Yeah, 1 over, that's what, same thing.
Right.
But it's 1 over 30.48. Yeah, I mean, oh yeah, so I just put it into the calculator, I got that out. So 1 over 30.48. Same thing. Yeah. Same thing. 1 over 30.48. Yeah?
So do you know, between D and B, you know, your minus and minus changes to plus straight away then, does it?
You will here, yeah.
What you do there then,
Yeah.
the X, the 25 over 762.
Or to be.
I would there just
Yeah.
finish. Probably finish there.
Yeah. It's slightly confusing.
So just using like so this is what I have the matrix in the question.
Yeah,
I need to find the so the
Yeah, I
formulas
understand that. It's just the minus and the minus.
Well, this
So
is
if you
definitely
multiply
minus.
now, I could make a mistake there. You see, that's what I'm thinking.
You could write it directly like that.
So you just do the last bit there again, the x.
Here. So
Yeah.
I'm going back to here. A inverse, which is this, times B. So if you look at the original thing, so the A is this, the X is the X and the Y, and the minus 2.7 and the 4.9 is the B.
Is it 762 over 25?
1 over that.
1 over 20.
Do you know the calculator?
I'm getting 762 over 25.
That's for the bottom.
Yeah. And it's
1 over that.
1 over that.
So 1 over 20. So use 760 over 25.
Yeah.
So that's, if you do 1 over that, it'll flip it. So 1 over 2/3 is 3 over 2. Yeah. Now multiplying matrices, what should you do first?
First row by the first column.
Before that even.
Single size matrix.
So what size? What size is this?
2 by 2.
And this?
2 by 1.
Yeah, they can be multiplied and you will get out of 2 by 1. Fix the 25 over 762. And you get out of 2 by 1. 2 rows. 1 column. Now just for space. Do you know what? It is. It is. I have to admit, I don't know where.
Very long or
The
something.
numbers are crazy.
No, it's not.
For 6 marks. 12. Okay,
yeah,
2 and a half, no, get that out.
Ah, stop.
At least.
Start taking over 15 minutes.
No, I actually, I do agree. I do agree.
It's an awful lot of work for 6 points.
Well,
Skip it.
We got 3 points there, look, for D there, the last question.
Yeah.
Mean and mean. Exactly.
but did any of you, not one of you answer that?
You didn't like that one either, right?
Yeah. the first year I taught kind of to yield at about 7 years ago, and just all this kind of, oh, I can't do it. And I kind of did a really soft final exam, and I think every single person got over 75. So it's not wrong enough. So no, it's not a great question. You're right. It's just with the decimals. It's not. No, I agree. Now this is row 1, column 1. You need to row 1 by column 1, and say like writing all that out is a pain. So I'm going to do that on the calculator. So 6.2 by minus 2.7 plus 1.2 by 4.9. And yeah, they're nasty, all numbers coming out. And the other one, this is second row, first column, so do second row by first column. Minus 3.7 by minus 2.7 plus 4.2 by 4.9. And yes, will it come out to something nice?
Sorry, they were the first row by 4 columns.
First row
By
first column. 6.2 by
Yeah.
that plus 1.2 by that. Now, this surely goes in. Now, what you can do now is multiply this by both of them. Now, if it makes a nice number, happy days, but otherwise, I'll definitely agree that it's not a really nice question at all.
It doesn't make a nice number.
It doesn't, no. So, you know, you can.
You just leave it like that.
You could leave it like that. I'd be giving full marks there, and probably no matter what you do, I would give full marks here. Like this is the bit I'm interested in. This is the bit I'm interested in.
That is recorded there, isn't it?
Yeah, this is the bit I'm interested in. Now maybe we'll multiply it in, but it's just not really coming out very nice. nice question. There's another reason. Okay, it's not nice. It's not nice. It's not a nice question because it's just a bit messy with the decimals. There is another reason. When you're working with matrices, you should never round. That's why I'm using fractions here rather than decimals. But that's not really nice in an exam. So